In networks, we have seen introduction of network elements, that is introduction. Then we have gone for simplification analysis or analysis techniques, that I named it as general analysis technique, because any circuit or any technique for any circuit. That's the part 1. Part 2 is specific analysis techniques. In that, each technique for a specific circuit, that's why I named it as specific. Now, having seen this analysis techniques, now we are entering into applications. The first application is time response. In any system, we have 2 applications primarily: time response, frequency response. We want to see how the system is responding in terms of time. That's called time response, in which we can easily understand the speed, how fast it is rising. All such things will be seen now. In the world today, speed has become most important. So, this time response will tell us how fast it is responding. So, and then we will go into frequency response, that is how frequency responds. Finally, 2-port networks. Therefore, 2 analysis techniques, 3 applications. That's all about networks. So, today we are going to enter into the first part application wise to see the time response. Generally, this is called transient analysis, because there is a transient part. Transient means how much time it takes to go before steady state. So, transient is basically how it is responding at the initial state, before switching and after switching. That's why this is generally named as transient analysis, but the best title would be analysis of circuits having transient part, because this we are not only going to study transient part, but also steady state part. Everything will rise slowly in terms of time and go to steady state. Even in human life it is the same. Any new things we do, we will always go for transient and then go to steady state. That's why we always say teenage is a transient state, and after teens we call it as steady state. So, this is having transient analysis, means transient part as well steady state part. So, the best title would be time response. That's why I named both the transient analysis or time response of a circuit. Let us see in this as an introduction. Sudden changes in the network parameters and characteristics of elements are called transients. The word transient I am trying to define. Transient means sudden changes, the simple English meaning sudden change. Then transient are occurred in a circuit when the circuit contains energy storage elements like LC, etc. So, transient occurs only for energy storage elements. Why? For storing energy, every element requires some time. You can't develop energy, or no element develops energy within no time. So, it takes some time. That time we call it as transient. These transients are observed in the circuit when immediately after switch on or off. So, when you are really changing the switch, there will be definitely some lapse in responding to that switch. Considering that lapse, or how much what are the changes occurred, is called transient. Then third sentence to say that transient are occurred in both AC as well as DC. So, I am not saying transient is only for DC, it is as well for AC, but DC transients are more dangerous than AC. For example, if you suddenly give DC to a capacitor, what happens? If the total voltage is pushed upon the capacitor, it can't charge within no time. That's why it is very dangerous. So, you can have AC, I mean not sine and cos, I only mean something depends on time. So, indirectly speaking, time independent and time dependent. You can give both inputs as inputs for this transient circuit. So, this is basic definition and understanding the words before we enter into the actual subject. Then let us go for an example. Suppose there is an equation di by dt plus pi is equal to q. This is an equation in this where q is input, I is output. So, this is a general equation you find in mathematics. I am starting my story there. If you say di by dt plus pi is equal to q, we call it as a first order system. As you know, any system mathematically represented in the form of integrals and differentials. So, we normally say every system is nth order differential. But to reduce the complexity in the introductory level, I am taking a first order system. Then, what would be the solution for the above equation? Solution for above equation is I of t is equal to e power minus pt, q into e power plus pt dt plus k into e power minus pt. Now, look at this. And this first part we call it as particular integral. Second part we call it as complementary function. These are the two words that mathematics people use, but engineers call it in a different way. The particular integrals is also called steady state response or forced response or zero input response. Let me talk to you very simply. Look at this. Suppose q is force. That's why we call it as forced response. Force means input. You are forcing the circuit or a system to work. That's why in general in a physics every force is called input. So, forced response. Suppose if input is 0, that's called q is 0. What do you get? That is this. So, you can call this as, these are the names, particular steady state response also. Why steady state? Because this is not having any t. Why, you know why this is not having t? E power minus pt, e power plus pt will cancel. If they cancel, what will happen? You have got something independent of time. If you get something independent of time, we call it as steady state, whereas this depends on time. So, it is called transient, complementary and so on. So, this is how I am just introducing in every function, in every time dependent response, you have a steady state as well transient. These are the two ideas. To give an example, I am going to show from a graph. Look at this graph. Suppose this is the response of the graph. Okay? The first part is called transient response. Second part is called steady state response. You see that? This is all depending on time. In fact, when you say switch is on, most current should flow. But switch is not really on as you think. We normally think switch is when you on, the light is glowing. But that's not going to happen. For some time it will take on off, and slowly it will come to steady state. So, this is called transient response because it is changing with time. This is called steady state because independent of time, steadily growing. So, that is why you have two responses, please. And the transient response is also called natural response. You know why it is called natural response? If you put input 0, the circuit has its own natural response. So, somebody is acting by himself, we call natural thing. If they are being forced by somebody, we call forced response, something like that. So, it is a day-to-day application, it is a very general thing. Somebody thinking by himself, that is called natural. Somebody is excited by somebody, that is called forced. So, every system or a circuit has natural response, forced response. Natural means without input, that is transient. This is forced, steady state. So, this is how I am slowly explaining what is the main difference between steady state here and transient here. Now, let me go to another important definition, that is called time constant. Time constant, you see these two words. It is time and it is constant. It's a very interesting definition I have. If you see RL, L by R, if you see the units and dimensions, you will get seconds. So L by R is a time constant, RC is a time constant, because R and C also, if you substitute what you call dimensions and units, you will also get a second. So you are getting the unit called second, that's why it is called time. So L by R is not simply L and R, it is representing time. R and C is representing time, so it is time. But why it is constant? At that value, at that time, it is almost independent of time. For example, look at here. Please look at here. If you go to this value, slowly it is depending on time, then finally it is going to steady state. So if you take this one depending on time, this is time response, this is steady state. So transient and steady state. Under what conditions we call transients? This one, below phi tau. After phi tau, if you observe, for example, e power minus t by tau. In the place of t, if you substitute phi tau, that becomes e power minus 5. E power minus 5 is almost 0 if you mathematically calculate. That means by the time it reaches phi tau, it is almost reaching to a steady state. It may go up and stay there, it may go to 0 and stay there. So at a higher value it stays there, steady state, at a lower value it becomes steady state. So therefore it will almost reach the steady state. That's why the time constant is defined in terms of the value called phi tau. So this is current, this is the time axis. Slowly current is rising. So this is how a definition is made, and that's why I am giving the definition. Time constant is nothing but the time at which the response is independent of time. That's why I said constant. That's how the definition I brought it. For any system, the time required to reach this steady state value 5 times of the time constant, that is called steady state. So this is another important definition you must appreciate before really going to the actualities. That's called time constant. Now let me define different time constants. As I just mentioned, L by R. For RL circuit, L by R. For RC circuit, RC. As I told you, if you see the units and dimensions, you will get L by R is second, R and C also second. This is the equation for voltage and current also same. By power and energy, what you can see is power means square. That means you will get by root 2. That root 2 whole square becomes 2 here. So L by 2R, RC by 2. So for voltage and current you get L by R. For power and energy you get by 2. So that's why these are the different ways of defining time constant. So now having got the time constant, now I am entering to discuss with you what are the characteristics of each element. As we know, in networks there are 3 basic elements. I am going to deal with each element, how they are going to respond. Just before switching, we call it a 0 minus. 0 minus means just before. Just after switching, we are going to say 0 plus. To use that word just, we have brought this idea called 0 minus just before, 0 plus just after. So follow this small idea, 0 plus and 0 minus. Now resistor is not energy storage element. In fact, we call that as power dissipating element. So it's not an energy storaging element. So resistor is not an energy storing element, and hence energy can change instantaneously. Suppose if it is a storing element, it needs some time to store. That means just before switching, whatever is there will be there just after switching. Why? Every energy storage element requires some time to store. When you say energy storage, it needs some time to develop it. So it can't develop within no time, whereas resistor is not storing at all. Therefore, whatever is there need not continue. Suppose it was 0 before, it can easily increase. Whereas in inductor and capacitor, they need some time. That means whatever is there before will be continued. So in resistor, energy just before switching need not be equal to just after switching. Please observe here, energy 0 plus need not be equal to 0 minus. They can be different. That means, for example, just before switching, if it is 0, just after switching it can be something, because it is not storing, it doesn't require any time. Therefore energy can change, power can change, and therefore voltage can change, current can change. Therefore voltage and currents are changes instantaneously in the resistor. They can change instantaneously. That means just before switching, just after switching, they both are same. In other words, its initial and final characteristics are same. They can have different characteristics. One is different, other is different. So you don't need to have the same values, because they can change, because they are not energy storage elements. So resistor, finally I am concluding, voltage across resistor just after need not be equal to just before. Current also need not be equal. So current can change, voltage can change instantaneously. That's the meaning. Now let me take you for inductor. When you talk about an inductor, it is an energy storage element, as I just mentioned, and hence every energy cannot change instantaneously. It takes some time. It needs some time. 0 plus, 0 minus. That means what? Whatever is there just before switching, same thing should be there after switching. You can't have two values. For example, imagine a student, imagine a human being. He cannot understand. He needs some time. When he needs some time, what happens is, whatever you tell him now, and then suppose you don't say anything now, then suddenly tell him, what will happen? He says, I can't remember. He needs some time to capture it. So when they need some time to capture, you can't expect sudden change. Even now, if I am very fast in teaching, you can't understand. Every human being needs some time to understand. So maybe you will be repeating this to understand also. Then that's why whatever you have, you cannot achieve something within no time. You need some time to understand, some time to capture. Therefore, any system requires that particularly energy storage element. E0 plus is equal to E0 minus. Whatever is here, that cannot change. Therefore, what is energy of an inductor? Half Li square. Half Li square. So 0 plus is equal to 0 minus. In other words, in an inductor, current is not changing. Please remember, inductor stores energy in the form of current. When inductor is storing energy in the form of current, if energy is not changing, automatically current cannot change. This is how we say inductor cannot change current instantaneously. This is the best way that I thought I could make the things very simple. I brought an equation of energy storage concept. Every energy storage concept will take some time. Therefore, energy cannot change. Therefore, current cannot change. That's about physically you can understand this way. Then I took graphically. I want to explain the same concept graphically. It is a little difficult than the previous, but the conclusion you already understood, but slowly understand here. Look at here. L di by dt is the voltage. VL is equal to L di by dt. Okay. Now, suppose L is equal to 1. Therefore, di by dt becomes VL. So all this graph I have made by taking L is equal to 1. Now look at. Suppose current is changing like this. what happens now? What will be the inductor voltage? Answer is very simple. Differentiation of a ramp is step. And you see there, differentiation of a constant is 0. A simple mathematics says differentiation of constant is 0, this becomes here. So please appreciate this is a fixed value, finite value. Now I am giving a second option. I am slowly decreasing this value. If I am decreasing this A, what is happening is this is increasing. Why? Look at here. The change in time is decreasing. That means what should happen? VL should increase. If dt is decreasing, VL should automatically increase. Then finally I brought a terrible thing. Suppose suddenly it is increasing. Current is suddenly increasing. That means what? The change in the time how much? 0. Here the change in time is small. Here the change in time is large. 0 change. If dt is 0, what should become VL? If dt is 0, VL should become infinity. Infinity cannot be accepted. Therefore, third case cannot be accepted. That's a very simple way to appreciate. Let me try. So once again, as time is decreasing, change in the time is 0 here, automatically this becomes infinity. Now what should I conclude? As infinity is not possible, change in the current is not possible with no time. You please observe this one. Before 0, current is 0. Just after 0, there is a current. That's not accepted. Here you see, before 0 it is 0, after also 0, because slowly rising. Here you see, before it is 0, after also 0. So whenever before 0 and after 0, voltage is finite. 0 before, after before also 0 is valid. But 0 current before and suddenly jumping, because dt is 0, it is end up in infinity. So please understand, therefore, as infinite voltage is meaningless, change is meaningless. Therefore, what should happen? Current cannot change instantaneously. This is another logic to say graphically. If current is changing from 0 to some value, suddenly voltage is becoming infinity. So that's not accepted. So current cannot change instantaneously in an inductor. Now I took one small idea. This is graphical concept. I took some mathematical concept. Same logic I want to bring out mathematically. For example, V is equal to L di by dt, that everybody knows. As dt tends to 0, okay, because time is always changing. Please remember, I am not saying dt 0. I am saying dt tends to 0 because dt 0 is illogical. Why? There may be anything that does not change in the world, but there is one thing that changes always in the world is time. Your qualifications may not change, but time will always change. That's why time and tide never wait for anybody. So if I say dt is equal to 0, it's illogical. So I am carefully saying dt tends to 0. Please observe that. In that, suppose if di is 0, 0 by 0 is undefined. Some students are arguing with me saying, sir, this is di is 0, dt also 0, it is undefined. I never said dt is 0. As I said, dt tends to 0. Look at here. So 0 by tends to 0 is 0. So if di is 0, voltage is becoming 0. Accepted. By mistake, if di is not 0, you will end up as infinity. Suppose something by tends to infinity, this will be going to infinite. Infinity is not accepted. 0 is accepted. 0 voltage accepted. Therefore, di has to be 0. Di means what? Change in current. Change in current means what? I0 plus minus I0 minus is equal to 0. That means voltage current before switching and after switching is equal. This is another way to look at why current cannot change instantaneously. Therefore, please follow. There are three approaches I took. One is physical approach, energy storage concept. Second is graphical approach, how to say infinite voltage is coming, that's why it is not accepted. Third is mathematical approach, and here also saying 0 is valid, infinite is not valid. In everything, by mistake, if current changes in an inductor instantaneously, by mistake if current changes in inductor instantaneously, voltage is becoming how much? Infinity. And infinite is not accepted, therefore change is not accepted, therefore no change. No changes means before and after switching current is same. So altogether, in an inductor current does not change instantaneously. But please observe, when I am saying current is not changing instantaneously, I am not saying voltage cannot change. Please understand, in a resistor current can change, voltage can change. In an inductor current cannot change, but voltage can change. So just because I said current is not changing, you don't simply conclude and saying voltage cannot change. I am only saying current cannot change instantaneously in an inductor. Now let me take you to capacitor. Capacitor actually is also energy storing element. Again the same logic. Now I have discussed about inductor, I will simply say as we discussed earlier. But only one point. Inductor stores in the form of current, but capacitor stores the energy in the form of voltage. Now please observe here, I made three statements. Energy cannot change instantaneously, therefore energy just after switching is same as just before. As I told you, for some people they can't understand within no time, same thing. Now what is energy in a capacitor? Half CV square. So half CV square is equal to half CV square. If you cancel them, voltage cannot change instantaneously. Therefore, the point is clear. Why voltage is not changing? Because energy cannot change. If it is a storing element, it needs little bit time. Therefore, just before, just after, you cannot observe any change. Therefore, voltage across capacitor cannot change instantaneously. That is what I said, physical explanation I have given. This is the simplest. I tried my level best to make the students understand, because there are several approaches, but this found to be very easy for every student to understand. This I brought myself. Then let me take you to something called graphical. When you say graphical, same logic. Look at here, IC is equal to C dVc by dt. Now, if voltage changing, current is existing. If voltage changing, current is existing. If voltage suddenly changing, current is infinity. Just like previous, once again. Look at here, before switching 0, after switching also 0, and differentiation of ramp is step. This differentiation of ramp is also step. But if this is suddenly raising, how much I should get? Infinity. Why? Same logic I mentioned. The change in the time is 0. When the change in the time is 0, look at here, you put 0 here, something by 0 is infinite. So infinite is not possible, therefore third case is not possible. What is third case? Before switching it is 0, after switching it is infinity. So 0 and infinity is not possible. You cannot have 0 value and suddenly finite value. So this is not allowed, this is allowed, slowly changing is allowed. So therefore finally current cannot change instantaneously. Voltage cannot change instantaneously, and hence by mistake if voltage changes instantaneously, you are end up with current as infinite. Look at these two. So it's a graphical approach. Now let me talk in a mathematical approach. I took this equation as it is. I is equal to C into dV by dt. As dt is 0, suppose as dt is 0, now if dV is 0, 0 by something is 0, then current is becoming 0. 0 current is accepted. That's why dV can be 0. If change is 0 means what? Before and after is 0, that means both are equal. There is no change. Indirectly we are saying no change in the voltage. No change in the voltage means capacitor is not able to change. So this is what I am explaining about why capacitor cannot change its voltage instantaneously. Therefore, please follow. 3 elements we have seen: resistor, inductor, capacitor. When you see resistor, inductor, capacitor, there are 6 things to talk. In resistor, both voltage and current change. In inductor, current doesn't change, but voltage can change. In capacitor, voltage will not change, but current can change. So please remember, out of 6 things, only 2 things are not changing. Don't be hasty to conclude and confuse. When I am saying transients, only 2 things you need to remember. Current in an inductor cannot change, and voltage in a capacitor or across a capacitor cannot change. Except these 2, all others will change. You can accept it. This is one way to say independent elements responding to time. So far we discussed about independent elements responding to time. Now I am going to take you, if these elements are used in a circuit, how are they responding? So first we saw independent elements, now we will see how these elements are used in a circuit. That's about independent. Now I am taking to analysis. Now before we go into transient analysis, let me conclude what we discussed. First point, inductor. In an inductor, current cannot be changed instantaneously, and hence it is open circuit. See, please remember, some students mugging up certain things and spoiling the whole affair. Never say the status of inductor based on the switch. Switch is closed, inductor is open. Don't say like that. I gave a very simple approach. Follow. You will be perfectly right. I will tell you a small thing. If inductor is connected to source, it has a privilege to develop current. Then it will current, a charge current heavily. Heavy current means short circuit. If inductor has no privilege to connect to the source, it cannot develop current. If inductor is not connected to source, it cannot develop current. That means what? No current means open circuit. Tell like that. Don't say short circuit, open circuit and spoil the whole affair. Don't worry about switch is short or open. Don't worry about inductor is short or open. Worry about only one statement I am saying. Is inductor connected to source? It has a privilege to develop current. Developing full current means long time means full current. Full current is short circuit. So say always taken more current and then say short circuit. Don't say short circuit and then open it. Similarly, if it is a capacitor, is it connected to source? Then it will develop voltage. It has developed voltage for long time means what? More voltage. More voltage means what? Open circuit. So more voltage is open circuit. More current is short circuit. It all depends on whether they are connected to source or not. So please don't make some mug up anything or memorize and then spoil the whole affair. Good. Therefore, current cannot change. After a long time, it can develop more current and hence it is short circuit. So inductor acting as a short circuit. Similarly, let me talk to a capacitor. Immediately after switching, voltage cannot be charged instantaneously, and hence it is short circuit. Zero voltage means short circuit. After a long time, it can take more voltage. It is taking more voltage means it is acting as open circuit. I will also tell you more voltage means why it is open circuit. I will tell you when I go to circuits. Please don't mug up anything, just apply, you will enjoy this circuit. And switching is the most important thing in engineering today. For example, you are talking about a computer. You want to make it fast, and people are interested to know how to decrease the switch or how to make it fast. Switching. Okay. Now, when you want to analyze transients, I have taken three approaches. One is Laplace transform method, I said S domain. Second is integral differential method, T domain, time. Inspection method, I call it as direct method. For objective questions, you can take always a direct method, because as I've been mentioning, getting an answer is not important. How fast you get the answer is important. So I am going to use these three techniques in the next lecture, not now. But I'll prepare you for all of them. So today is to prepare you for transient analysis. So three approaches I am going to take, and you can see. I will tell you when is this approach also. For example, if you are going for time domain, you can go for time domain if the differential equation is first order. If the differential equation is first order, you can enjoy time domain directly. And if the differential equation or the system is becoming much complex, go for Laplace transform. Actually, in BTech, there are books talking about solving a problem in time domain, same problem solving in S domain. But here we don't do that. 90% will go S domain, because Laplace is always better. Okay. Inspection method is not always easy. When you are using inspection method, you must know initial values and final values. If initial values and final values are clear, use this method. And the third method, inspection method, is going to be the fastest method. And Laplace, of course, is good, because even if it is a single order differential, you may be tempted to go for time domain. But if input is complex, what do you do? Again, you go Laplace. Therefore, I will be happy to handle this inspection method, Laplace method. But time domain, I will just show you to show how to handle it. Not to be ignorant of this method, but otherwise our practice will be inspection or Laplace. So I am going to attack the problems or crack the exam in one of these three methods. You can go on waiting as I am going to teach these three methods in the analysis and problems. Now, as I said, we are going to Laplace. We need to know a little bit about Laplace. We don't need to know everything like a signals and system. Anyway, signals and system subject is there, you can study that as a separate thing. But this tool I am taking today because I am going to use it just for minimal thing. This is not the exhaustive lecture on Laplace, please. There is a definition. F of s is equal to minus infinity e power minus st f of t dt. This e power minus st is generally called kernel, because this is transforming. You are substituting limit for t. When you substitute limit for t, t is replaced, therefore the answer will come in yes. Because some people are confusing, that's why I am telling. When there is a dt here, you are substituting for t, therefore t is eliminated here, the total will be left in terms of yes. Similarly, look at here. When you go for inverse Laplace transform, ds is here, that means you are substituting for yes. When you substitute for yes, s is eliminated and the answer should be in terms of time. Very simple thought. Simply first understand mathematics, then you can understand anything. So, this is the definition for Laplace. One thing you must understand, as a matter of fact, you are multiplying with e power minus st. That means what? When you multiply with negative, exponential negative is smaller, in fact less than 1. You are multiplying a new function with less than 1. Indirectly, you are making it smaller. So whenever you take a transform, you are making it smaller. By making it small, I mean finite, analysis becomes simple. That's a simple idea behind transforms. So this is the definition of Laplace transform. Then we need to see properties. Addition. Addition property is called linearity. If you take two functions and then take the Laplace transform of two functions, you know what will happen? It is Laplace of this one and this one. You know, in mathematics you must understand one small thing. Integral is a linear operator. Therefore, all transforms will satisfy linearity. All transforms. So you don't need to take too much of time to say that word. The operator you have taken is integral, and that integral is linear. Therefore, transform satisfies linearity. Actually, the word integral means what? Integral means elongated S. Normally, we have three shapes of S. S is meant for sum. If you pull it, it will become integral. If you twist it, it will become sigma. That is also sum. So S and integral and sigma, they are the three shapes of the same thing. All these three are telling one word again and again, sum, sum, sum. That's the meaning. So then we'll go for the second definition, second one, time differentiation, because we are talking about differential equations. And inductor and capacitor and resistor, they're all linked with the differential equation. That's why I am jumping to differential equation. Then if you take Laplace of a differentiation, s into f of s minus f of 0. And this depends on the initial value. So third one, time integration. Integration of that will become 1 by s. Please remember, this integration limit is 0 to t. It's not minus infinity to t. Convolution. Convolution in time domain is multiplication in s domain. Convolution means basically area under the curve. That is simply multiplication. Time shift is also important because we are dealing with shifting time. So f of t minus a, u of t, you can take it for granted. So when you shift in time domain, it is multiplication in s domain. But please observe this minus, this minus. Multiplication in time domain, exponential here. Similarly, frequency shifting, you are shifting here, f of s minus a. So shifting in frequency or s domain is e power at. Now please remember, s is not called frequency. It's called, some people call it as a complex frequency. In fact, complex frequency means it's not a frequency. Because by definition, frequency means number of cycles per second. Frequency cannot be negative, cannot be complex. Therefore, s is called neither time nor frequency domain. It is time domain operator. So don't call it as time. T is time domain. F is frequency domain. S is neither that nor this, but time domain operator. This is an operator used for analysis. That's why you may end up analysis with F, but you will never end up with analysis with S, because it's only used to simplify the analysis. At the end, you are back to time domain. That's why we always take Laplace transform and then take inverse transform. So frequency differentiation. Suppose if we differentiate with frequency, this is not very much useful to us. Only two things are very useful. One is time differentiation, other is frequency differentiation. Then frequency integration, that is by t, scaling 1 by s, f of s by s. So these are the some just hints I gave. Now let me go to basic transforms required. Laplace of an impulse is 1. And this is a very interesting story. Laplace transform of impulse is 1. That is one thing. Second, Fourier of impulse is also 1. Jet transform of impulse is 1. The point is, any transform of impulse is 1, otherwise the transform has to be checked off. Then ut 1 by s, tut 1 by s square, 1 by s power s, e power minus at, 1 by s plus a. Sine is very important because we give sine and cosine. A by s square plus a square. Cos is s by s plus a, s square plus a square. Then you see, as I mentioned earlier, multiplying with exponent. When you multiply with exponent, what comes? Opposite term comes, s minus b, s minus. Wherever s is there, put s minus b. Shift in s domain. Similarly, s plus b, s plus b. So this is for e power minus bt cos. So please remember, minus here, plus here, minus here. Then minus here, so plus here. So these are the transforms list I gave for you to follow the techniques. Now, initial value theorem and final value theorem. It is, initial value means f of 0. When time is tending to 0, s is tending to infinity. So limit s tends 0, s into f of s. This is basically a theorem. But look at here. It is applicable to the systems which are non-periodic and stable. The point is there, non-periodic and non-stable. That means, but what I mean is, if it is a periodic function, what is the initial value? Take for example sine wave. Starting value is 0. After 2 pi, it's again 0. Then how can you talk about final value for such a thing? Initial value, how can you take? Initial value in a sine is 0 for every 2 pi. So you can't use this theorem. Final value of sine is every time it is plus 1. So that's why for that's applicable only for periodic, only for non-periodic and stable. Suppose it is periodic and unstable, it's not valid. Anyway, I will illustrate in the next lecture. Final value also same. When t tends to infinity, s tends to 0, s into f of s. If it is periodic, you can't talk about. So don't talk about, or you can simply say initial value and final value theorems are undefined for periodic signals. That has become a very serious question in GATE exam, every time repeated. This question comes in 3 subjects, please. Signals and system, networks and controls. As I have been telling, all these 3 subjects are same. That's why these theorems you should be careful. You can apply only when they are non-periodic. If it is periodic, don't talk about initial and final, because initial value is repeated, final value is repeated. That's why they are called periodic. Right? Now, what is inspection method? Using Laplace transform and other methods, they take more time and difficult to solve complex networks. Very much time. For example, you talk about Laplace transform. You have to take transform. You have to take inverse transform. Sometimes inspection method becomes better. That's why, suppose there is a statement or a proverb, when you want to pluck out a small thing, why are you using big axe? It may cut your legs also. So don't use tools for small thing. For small thing, if you are using tools, it is very bad. For example, 2 into 2 is 4, you are using a calculator, is very bad. It takes so much time. So that's why this inspection method will save a lot of time. According to inspection method, total response is equal to final value plus initial value minus final value e power minus t by t. Once again, final value plus initial value minus final value e power minus t by t. Good. That means where f is a final value, I is the initial value, and this is applicable to which network? Because generally students are normally doing with what you call a capacitor. They are under impression that it is valid only for capacitor. No. Whatever the subject you study, this technique is used. It is used in EDC, electronics and op-amps also. Let there be any RC component, RL component. How much voltage is initial, what is final, that will decide your final value. Now remember, it is applicable for all types of networks, elements, provided the respective initial and final values are taken. If you want across L, put initial value, final value across L. If you want across C, put the initial value, final value across C. So whatever the element you are talking, same element provided. Even for, you can apply for the resistor also. Normally people never apply that, but that's why people are in a bad impression that it's valid only for capacitor. You can apply for resistor. For example, if it is a low pass filter like RC, initial and final value of capacitor, because you take across capacitor. If it is high pass filter, C and R, outputs across taken R. That means initial and final values are taken for resistor, not the capacitor. That's why if you take initial and final values of any element, that you can use for respective elements has to be taken. So I am taking an example of a first problem. Obtain the value of phi at t is equal to 0 for the circuit shown. Very simple. This is the circuit shown, RL. Now for every circuit I am going to do only one question, I. For every circuit I will be drawing the circuit for t0 minus, that means just before switching and just after switching. Please observe, this switch will tell so many stories, so much of information. There is I here. When is it closed? At t equal to 0. That means before t0 what happened? Switch is open. Now let us calculate current. Just before switching, what happened to switch? Open circuit. Now is this inductor connected to source? No. Why this inductor is not connected to source? Because switch is closed. Then what happened here? This is not developing any current, that's why open circuit. So current in this circuit is 0. Similarly, switch is closed. Look at here, switch is open but switch is closed. When the switch is closed, what will happen to inductor current now? As we already said, current through an inductor cannot change instantaneously. Therefore, please observe, this cannot change. Whatever is here is here. So I am opening this because current is 0. And current is 0 because this inductor is not connected to source. So simple. And finally current is 0. Let me take you to second problem. Obtain the current I through the circuit, same. Earlier problem I took RL, now I am taking RC. Now please observe, same thing, instead of capacitor I have put, instead of inductor I have put capacitor. Will you see now? Just before switching, switch is open. Now please help me. Is this capacitor connected to source? No. If this capacitor is not connected to source, will it develop any voltage? No. Capacitor develops voltage. Inductor develops current. So no voltage. So no voltage here. That means even after switching, voltage is 0 because whatever the voltage developed here, which is 0, is passed on here. Voltage across capacitor cannot change. Therefore, what is the current in this circuit? It is short circuit. You know why the capacitor is short circuit? Once I am going to repeating. 3 words please follow. This capacitor not connected to source. Therefore, it could not develop any voltage. No voltage means short circuit. That is here. Therefore, current is V by R. Current is V by R. Now, I am putting all the 3. I want to tell you what happens if I put all the 3. RLC. As you can see, what happens? Switch is closed, open. Inductor is could not develop current. Inductor could not develop current means what? No current. No current means what? Open circuit. Capacitor could not develop any voltage. If capacitor is not developing voltage means what? Short circuit. So this is open circuit, this is short circuit, and switch was already open. One open is sufficient, therefore current is 0. Suppose if you want to say electrical wire is cut, you don't need to cut 2 times. One cut is okay, current is 0. Similarly, now switch is closed as you observe here. Ready? The switch which was open here is closed. But what happens to inductor? Cannot change. Inductor is open here, therefore remains to open. Capacitor is short, remains short. But still one open circuit is sufficient, therefore total current is 0. So this is an argument to talk about serial circuits. Now I am going to take you parallel circuits. How the RLC component respond to voltage in series, I spoke. I am going to take 3 examples, 3 problems to show you how the same RLC component is going to respond to current source, that too in parallel. So please observe, you will follow. The question is not calculating current, question is calculating voltage, because source given is current and moreover parallel circuit, voltage I want. Now please observe this key. This switch is open at t equal to 0. That means what? Switch is open at t equal to 0, but that means before 0 it was closed. I am going to show you. Slowly, carefully observe. Now follow me. Before switching, switch was open, closed. Initially it was closed. At t equal to 0 plus it was open. So closed switch, open switch. Now is the inductor connected to source? Most of the students are saying this is connected. It is true, seems to be connected. It is true this inductor is connected, but because this is short circuit, they got shorted. Look at here, shorted. Too much of current is going here, no current came here. When no current came here, capacitor, this being a capacitor could not develop any voltage. Once again I am repeating, please follow, this is a capacitor. It's not connected to source because current is going here and here. No current is coming, therefore it could not develop any voltage. No voltage means what? Short circuit. Same voltage, whichever is 0, will follow here because capacitor cannot change its voltage instantaneously. Though the switch is open and output is 0 here. So output voltage 0 here, output voltage 0 here, because capacitor cannot change its voltage instantaneously. This is about how a capacitor responding to current source, that in parallel. Now let me go. One more thing, last but one. Obtain voltage at t equal to 0. Same elements. Only thing is instead of capacitor I am using inductor. Now observe slowly. Is the inductor connected to source? No. Seems to be connected, but because this is short circuit, this is completely going here. No current is coming here. So inductor could not develop any current. No current. No current means what? Open circuit, short circuit. And what is the voltage across this element? This is a voltage across this element also 0. Why? Because this short circuit is appearing. So voltage is 0, but current in the inductor is 0. Now look at here. Switch is open. It is supplying current to inductor. Then what happens to inductor? We already said inductor cannot change its current instantaneously. Therefore, this current is the same as this. Though there is a facility to change current, but because inductor cannot change its current instantaneously, this is here. Now how much is the voltage? Look at here. This is open circuit, therefore what are the current you have here into R is the voltage. That's called I into R is the voltage. Okay. This is 0, but there is a voltage. This is called RL circuit. Now lastly, all the 3 I am keeping. RLC. We want again voltage. So what's going to happen? First, switch was closed. When switch is closed, is inductor develops current? No, because this is here and here. No current here. No current means open circuit. No voltage for capacitor. Short circuit. So capacitor is shorted, inductor is open. What is the voltage here? 0. Why? Because this short circuit will directly appear here. Similarly, switch is open, but resistor is here. Inductor cannot change, capacitor cannot change. Inductor same, no current, no current. Capacitor same, no voltage, no voltage. What is the output final voltage? Because this is shorted, this is 0. Please observe, 2 short circuits 0, 1 short circuit also 0. So because capacitor is present in this circuit, voltage is not changing. So this is how I have defined the meanings. The definitions are made clear. Then I have made you to understand how 3 components are responding individually. Then I made you to understand how the 3 components are responding in serially and parallelly in the presence of switch. So this is an introductory talk for transient analysis. The problems that have been asked in the exam we will be seeing in the next class.